My name is Ashni and here I'm presenting a demo on my project called Comparative Analysis of Brute Force and Divide and Conquer Outcomes for the Closest Paid Problem. I have implemented my project in Google Colab using Python language. The primary goal is to empirically compare the performance of algorithm 1 brute force, which has a time complexity of big O of n square, and the other algorithm is divide and conquer, which has a big O of complexity of big O of n log n. We have imported all the necessary Python libraries, and in the step 3, I have implemented brute force algorithm, and in the step 4, I have implemented divide and conquer algorithm. And the main part, which is the running the experiment, I'll show how I satisfy the project requirements. First, for compilation and a simple test case, I have used a small list of 5 points and run the algorithms on it. This will prove the function compile and they both produce the same correct minimum distance. And the main experiment, we tested the input sizes from 10,000 to 55,000 points. Each size was run 10 times and the average runtime was recorded to reduce the randomness. We visualize the results using tables and graphs to clearly compare the algorithms. Here you could see the table 1, which is a brute force algorithm 1, and the calculator constant was 2.58 e to the power of 7. And the second is divide and conquer algorithm table, which has a calculated constant of 1.20 e per 6. And the last step would be the graphs. We have three graphs, which is empirical running time comparison. The graph plots the raw empirical data of both algorithm 1 and algorithm 2. It will dramatically show how much more scalable algorithm 2 is. This is the visual representation of the graph 1. And in the second graph is for the algorithm 1 brute force, which is compares empirical time versus predicted time. And this is the graph 3, which is the for the algorithm to divide and conquer, which shows the difference between the empirical and the predicted time. The results clearly demonstrate the difference between the two approaches. For brute force, runtime grows quickly. For example, with 55,000 points, it took over 6 minutes to complete. In contrast, divide and conquer remained extremely efficient, taking less than 1 second for the same input. This graph confirms that the measured runtimes closely follow the expected theoretical growth patterns. In conclusion, while brute force is simple to implement, it becomes impractical for larger datasets. Divide and conquer, however, is highly efficient and scalable. This experiment result strongly supports the theoretical analysis, making divide and conquer the preferred algorithms for large scalable applications. Thank you.